What's up, everybody? Welcome back to yet another episode of Basic Chemistry 101 with Sihlebonani. My name is Sihlebonani, and today we are dealing with mass percentages.
Let's go. This is how every child that wants to make it one day. Zimbo say class and presence of mind is elsewhere. Bring out Uzuzani, Abna, already Alispani, and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they are written in focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help.
If you've been with us up to this point, let me take this opportunity to thank you for the support. We are nothing without you. And also, if you are just joining us, welcome. This is for you as well. Please subscribe so that we continue together. All right, since now that is out of the way, as a chemist or a chemical analyst, as you stumble upon a compound, what you're gonna want to know is the chemical formula of it. So one way of knowing the formula of such a compound would be the use of mass percentages. Now, mass percentages will be part of your quantitative analysis. Just knowing what is there, the elements that are there, that is your qualitative analysis. So if you have such amount of a compound and you have different elements that make up that compound, you're going to want to know how much of each element is there in a compound. So that is your mass percentages. So a mass percentage, I'm sure we all know how to calculate a percentage. So mass percentage would be your mass of your analyte, which is the element that you are looking for, divided by the mass of the whole compound times 100%. You can be asked for a mass percentage from just being given a chemical formula. For an example, you can be able to calculate a mass of formaldehyde. Now, how can you calculate from being just given a formula? You can use the molar mass, which is mass per day. They will ask you for a mass percentage for each element in that compound. So if they ask for a mass percentage of carbon, this would be, we'll use a molar mass of carbon divided by the molar mass of the whole compound, which would be CH2O times 100%. Now, molar mass of carbon is 12, right? Then the molar mass of formaldehyde is 30.0 grams per mole. So this would be times 100%. Then from here you would get 40%. So this means in formaldehyde there is 40% of carbon. You can do the same thing for even hydrogen. So your mass percent of hydrogen would be molar mass of hydrogen, because you have two hydrogens there, it would be 2 times 1.01 divided by 30 times 100%. Then you would get 6.73%. You can do the same thing for oxygen, but since these are 1, 2, 3 elements in one compound, you can add these two, and then you subtract from 100 to get the mass percentage of oxygen. That is one way of getting your mass percentage from a given chemical formula. Now, what happens when you are given the mass of the compound and you would want to know the mass of each individual atom in a compound? Now, this is where your mass percentages would come in. For an example, let's say you are given a mass of formaldehyde. Let's say they say it's 83.5 grams of formaldehyde. They want to know the mass of carbon and the mass of hydrogen and the mass of oxygen in 83.5 grams of formaldehyde. But now, from the previous example, since we know that carbon is 40% of formaldehyde, so to get a mass of carbon would be equal to 40% of formaldehyde, which is 83.5 grams. And this would give us 33.4 grams of carbon in 83.5. But if you were watching the last video, you can also get this thing from calculating the number of moles, which is 83.5 grams of formaldehyde. We change it to moles. So this is be 1 mole is equal to 30.0 grams. So this is 1 mole of formaldehyde. Then 1 mole of carbon is equal to 1 mole of formaldehyde, right? Then from here we can multiply by the mass of carbon, molar mass of carbon, which is 12 grams per mole. This should give us the same answer. So we are learning. We can do the same thing for hydrogen and oxygen. You know the mass percentage of hydrogen in formaldehyde. You know the mass percentage of oxygen in formaldehyde. Therefore, you can be able to calculate the mass of hydrogen and the mass of oxygen from formaldehyde. One other way that we can use mass percentages in calculation is when you do not know the formula but you want to determine it. Most chemical compounds or molecules contain carbon, hydrogen, and oxygen. Now, let's say you know that your compound contains these, but you don't know the formula. So how can you determine the formula or the mass percentage of these compounds? Mass percentage will lead us to the formula that we are looking for. But for now, let's focus on mass percentage. So what you can do, if you know that these are involved, you can use combustion, which is you burn this in oxygen, then you would get carbon dioxide, then you would get water. Now say when you burn this in oxygen, this was 4.0 0.24 milligrams. You burn it in oxygen, and then it gives you 6.21 milligram of carbon dioxide and 2.5 milligrams of water. Now they say calculate the mass percentage of carbon, oxygen, and hydrogen. Now what you can do is calculate because if you can see there's carbon here and oxygen, you can ignore oxygen and you calculate the mass percentage of hydrogen and carbon. And then from there, the mass percentages that you get, you can subtract from 100 to get the mass percentage of oxygen. An example would be to get the mass percent of carbon. We'll change this to the number of moles. 6.21 times 10 to the negative 3 grams. 1 mole of carbon dioxide is 44.0 grams of carbon dioxide. Now from here you would get the moles of carbon dioxide, but we are looking for carbon. So in carbon dioxide there is 1 mole of carbon in 1 mole of carbon dioxide. Then you multiply this by 12 grams per mole of carbon. Then you get the mass of carbon, which is 1.69 times 10 to the negative 3 grams. So this is 1.69 milligrams of carbon in our unknown compound. So we can get the mass percent of carbon, which is equal to mass of analyte divided by mass of whole compound, 4.24 milligrams times 100%, 39.9%. You can do the same thing for hydrogen. So for hydrogen, it's 2.5 times 10 to the negative 3 grams of water. 1 mole of H2O is 18 grams of H2O. Now we are looking for hydrogen. 1 mole of H2O will be 2 mole of hydrogen. And then mass of hydrogen would be 1.01 gram per mole. So this is hydrogen. Then your mass would be 2.85 times 10 to the negative 4 grams. Then once you have your mass of hydrogen, you can divide it by the mass of your whole compound. Multiply by 100, you get your mass percent of hydrogen, 6.72%. Now for oxygen, mass percent of oxygen would be 100 minus 39.9 minus 6.72. You get your answer. So for now, that is the types of calculations that involve mass percentages. What you can do is get some more problems so that you can practice you come back and look at what we spoke about, so that you get the gist of what mass percentages are, or how to use them in calculations. As you can see that we are getting deep into chemical calculations. We can move on from here and determine our actual compound, but I believe we can stop here so that you understand the concept of mass percentages. Thank you very much for watching. If you liked the video, or if you understood something, please like, and also if you have not already, please subscribe and help us grow. You can share to anyone who might need to understand mass percentages. Thank you very much. This has been Basic Chem 101 with Sihle Bonani. My name is Sihle Bonani, and we'll see you on the next video. Booyaka!